Okay, information for 427. Let's take a look at this homework assignment that you're getting today, the 88811 practice. If you haven't, either one of you haven't started it yet, you're basically looking at problem 8.7 and 8.11, parts A and E and A and B, and here's 8.7. So they want you to do A and E, or A and B first on this one. A and E. Yeah, A and E. So for a 1/4-inch diameter socket head cap screw, a hex socket head cap screw, which is not a hex head. It says socket. It's asking for the major and the major diameter, which it's given you here. The head diameter, the head height, normal size clearance hole, counterbore diameter, and counterbore depth. So for A and E, that's all you're doing is filling in that information. Most of it's going to be, if you look at the appendix, it's going to be. I don't have the book next to me this morning, of course. Like I said, it's that. Organizational effort that I haven't put into today, but I don't know that you're going to find the information for the hole for the counterbore. You're going to find in a table. I believe it's B7. Yeah, you'll find that. But the information for the head diameter, head height, and all that, you're going to have to figure using the formulas. And they're pretty simple. So we're going to go through that this morning. So you're doing 8.7 and then 8.11. And 8.11 is just a metric version of the same type of problems. The difference is that they're countersunk or countersink style cap screws. So the information you look up is going to have to be for countersunk clearance holes, not counterboard. So that's the only difference. Okay. And then, of course, another quiz. And then Wednesday, another quiz, which is due May 6th. See, this stuff's due May 6th. This due date for the assembly drawing is wrong, obviously. It's a week off. Because I guess I haven't modified everything in this for this week yet. I thought I had week 15 all done, but I think I missed a couple things down here for Wednesday because this still says 2019. This date hasn't been updated, but these two have. So I'll get that squared away. It's just a matter of actually, I can do this just by changing that to the 2020. Yee-hee. Look at
There
that.
you go. Perfect. Perfect.
But it didn't actually change the file. The file, if I open the file, the information on the inside will say 2019 still. So I have to go in and modify that to make it right. Although for 1 week, I might just say, who cares? No, I won't. Okay. So let's take a look at the PowerPoint for today. Give me just a sec here, and we should be good. So we're talking about both clearances, graded work. It's still it's a work in progress. I think the work due, more or less is probably fairly close. So let's take a look back on what we talked about last week. So we're looking at a unified and a metric thread note. The first position is the major diameter.
Right.
Second position is the threads per inch. Third position is thread form and series. The fourth position is the class of thread, which along with calling it external or internal and left hand or right hand is optional as long as it's a standard or the default values, which would be thread class of 2, whether it's external or internal, we don't normally call out. And if it's right hand, then you don't need to call out the hand. So in effect, their call out's basically going to be 3H-24 UNF, and that's it, unless there's something different. The thread class is other than 2, and it's left hand instead of right hand. And in that case, then if you're calling out the thread class, you should call out whether it's external or internal, just for consistency's sake. Number 7 then is going to be the depth of the full thread, and that's as long as it's not a through hole. If it's a through hole, then you usually don't have to call this out. Okay. Metric thread callout's pretty similar. The first position lets us know that it's metric form. Second position gives us the major diameter in millimeters. Third position is the pitch. Fourth position is the tolerance class, which again, as we said, in some ways is similar to the tolerance class for a fit between a shaft and a hole. At least it looks similar. I would say the information is not quite the same. So there's no calling out external or internal along with the tolerance class. And then fifth position is right or left hand. Again, if it's a right hand, not needed to be shown. And if this is the standard tolerance, which is what 6H, don't remember what it was. I'd have to go back and look. But so in order to keep from sticking my foot in my mouth, let me just say if it's something other than the default tolerance class, then you have to list it. If it isn't, then you don't. So your call out could be just M6 by 1. And then again, the depth if it's not a through hole. If it is a through hole, you can eliminate the depth. All right. So let's talk about bolt and screw clearances and how they interact with mating parts. Obviously, I guess visually you should be able to figure out that they bolts and screws attach one material with a clearance hole to another with a threaded hole. How do you determine the size of the clearance hole? Usually it depends on the major diameter and the type of fit, whether it's normal, close, or loose. Again, most of that you can find in tables. You may not find them in the text, but if you look at the shop manual, the little blue book, there's a good chance you'll find, when you're looking up clearance holes, you'll find a standard fit and a close fit and loose fit in the table. So realistically, the table should give you most of the information you need when you're trying to establish sizes for clearance holes or counter bores or counter sinks. So for normal fit clearance, usually If you don't have a table, you can assume at least most of the time people probably figure at least up to a half an inch that the clearance hole is going to be the diameter, the major diameter of the fastener plus a 32nd of an inch. So 32nd of an inch is basically 32 thousandths, 0.03125.
Mhm.
So if you split that up, it's about 16, between 15 and 16 thousandths per side. And when you couple that with like hole locations, if you're not doing geometric tolerancing and you're just, putting, like, say, a 3-place dimension on the hole location, well, that's going to be plus or minus, usually plus or minus 5 thousandths. So theoretically, then, if you've got a total of 15 on a side, the tapped hole could be short 5 thousandths, and the clearance hole location could be long 5 thousandths, and you should still be able to get it together. You should be able to make the two parts and bolt them up with 5 thousandths clearance on the side, or at least on one side, and an extra 10 thousandths and about 25 thousandths on the other side. But still, they should go together. So that's kind of a standard, I guess, 32nd for most of the fasteners that you'd use, which are probably going to fall in between a number 5 and a 7/16. If you're a machine designer, you're probably not going to use anything bigger than this for the most part. Most everything falls into categories of number 10s and quarters, quarter inch, 5/16, maybe 3/8. But when you look at the amount of stress that even a 3/8 bolt can withstand, they're pretty stout. So generally speaking, this is kind of the standard, the D plus 32nd. But there are tables that not only give you this information, but there should be tables out there that will tell you exactly what the clearance hole sizes should be for standard, loose, and close fit.
Yep, there are. I saw some online today.
Sure. And the same holds true for metric clearances. But these are nice tables to have. They're in the, like I said, they should be in the text. And again, you should find them in the shop reference manual too. And so, now we're talking about counter bores and countersinks. If the design, can't tolerate a bolt or screw thread, the screw head sticking out above the mating parts, well, then you got to put a counter bore in or a countersink. So how do you determine the counter bore diameter and the counter bore depth? Again, you're going to take the bolt and probably, if you don't have calipers, you're going to look up the bolt size and try to find the specs for it, which should give you the head diameter and the head height, and then you should be able to determine the size of the counter bore based on that. All right. So typically, for the height of the head, you're looking at the height of the counter bore, you're looking at the height of the head plus a 16th. For the counter bore depth, CH, and that 16th gives you a little bit of extra clearance so that the head is below the surface. Just in case there's, if you've put a tolerance on this depth, then that gives the machinist a little leeway. I mean, if it's a 3-place dimension, one, he's got to get the depth to within, say 5 thousandths. But if you give him a 2-place dimension, well, now you might have plus or minus 10 on your tolerance block. So you want to give him at least a 16th so that if he does come a little shallow, that the head's not going to be sticking up above the surface of the part. That's pretty, straightforward. And then the counterbore diameter is going to be the diameter of the head plus an eighth of an inch. So now you got a 16th on the side, which should be, depending on the size, should be a little bit more than the clearance hole, right? Because you don't really want the clearance between the head and the counterbore as being the deciding factor in how much tolerance you can have in this. Really, the clearance hole is the deciding factor. So it's a little bit more forgiving, the counterbore. And this particular bolt doesn't matter about wrench clearance because it's a socket head cap screw. So the Allen wrench fits on the inside of this. They should probably show the hidden lines of the hex that's internal in this, just so that folks that aren't in the know have kind of an understanding, or at least might ask a question about what we're seeing here. But you don't have to consider wrench clearance in order to, or socket clearance in order to be able to install this.
I think by leaving it the way they did, they still allow for those things like Torx screws and Phillips screws. And
True.
I've even seen flathead screws like that.
True. I mean, that is true. And if it were a hex, it would have a couple of lines here,
right,
representing the flats.
Exactly.
But not everybody knows that. You know what I mean? If you're inexperienced, and you're just starting out, and this is your first class, and you know nothing about fasteners, for example, then there might be some questions, which of course we could answer in any event. Countersinks. So pretty similar to counterbores. We know countersinks are basically an angled hole designed to recess the screws with angled heads. And typically, again, the counterbore or the countersink diameter is going to be the diameter of the head of the fastener plus an eighth of an inch. And again, what we're doing is giving us some clearance in order to make sure that the head of the fastener is below the surface. And it says Appendix B gives other counterbore sink and shaft clearance holes. I'm not sure.
It sort of does.
Yeah, it sort of does. Like I said, it's if you look at page B7, there's counterbore information there. And countersink. Well, a countersink is for just that's just for an edge breaker. It's just an edge breaker countersink. And then if you look on page, there is nothing for countersinks in the book. You basically have to use the formula that's on the that's on the slide here. So if you look at the head diameter, if you look on page B9 or B8, B8 tells you gives you information on the head height and how to figure that, and the head diameter, considering the theoretical sharps, right? Because they're not sharp like that. They are.
It's usually a little bit of a flat.
Yeah, they do have a flat on the corner here because you could hardly handle them, for one, if they didn't have that flat. They would be sharp, literally, and then and then they'd be ragged on top of it. So,
right.
So here's the deal about countersinks, though. Regardless of how big you make this countersink, once this fastener starts to contact the angled surface of the hole, it's locating this bolt automatically within this part. Within this part right here, it's locating that fastener. So regardless of how much clearance you have here, if this for some reason, if the angled part of the countersink were offset from the center of this were offset from the center of the clearance hole portion, then it could conceivably upset the location of this fastener within this part. I have seen that happen where where the way they made the part was the first thing they did was drill or bore the clearance hole, and then somebody came in later on with a counterboring or countersink tool and created the countersink. And the countersink tool, they didn't have it clamped up right, or it was
they probably got that. I've seen it where the book here specifies 90 degrees plus 2 minus none degrees in the drawing for it. But there's an 82 degree countersink out there, and a lot of people grab an 82 and don't realize it's not a 90.
Yeah, well, I can tell you right now that the 82 degree is the ANSI. So every ANSI fastener, quarter, 3/8, number 10 countersink has an 82 degree head to it. The metrics are 90 degrees.
Okay, but I guess the point I was trying to make though is if you get the wrong countersink in there, you can do exactly what you just said.
Correct.
You mess things up.
Right. And so what they wind up doing then is they wind up going way overboard on the diameter in order to get the right fastener in the wrong hole. Yep. And then instead of having full contact like you would like they show here, because this is on a different angle, you're actually just going to have point contact someplace. So it's not going to be very good in terms of gripping the part either. Or what could happen is if there is a fair amount of load on, say, the mating part, and there is some force that's trying to pull them apart, well, over time this point contact is going to wear down, and now all of a sudden this fastener is going to be loose. It's not going to be torqued to the value it should be anymore because that point got worn down, and so now the fastener loses its torque value. So yeah, you got to be careful about that. But that's one of the things about countersinks is that, so in my mind, I would not use countersinks, unless I absolutely had to. The other issue I've seen is where they've had parts that were supposed to be pinned together, and they used countersink holes. And what happened was they when they put the pins in and mated these two parts together and went to put the fasteners in, then the fasteners wouldn't go below the surface because they were offset enough. Or the other situation would be the hole has a plus or minus, even if they're right on the money, the hole locations probably have, for the tapped and clearance holes, have a plus or minus 5 thousandths tolerance on them. But a pin location usually has plus or minus 5 10,000ths of an inch location tolerance. So they bolt the thing together, and then they go to put the pins in, and the pins won't fit because now the pinholes are offset enough because it's this wedge action here between the fastener and the material that's locating the two parts. You say the holes could be right on, but and perfect, but if they're within the tolerance of their location, they could still make the pin locations go bad. So I would never use a countersink fastener in a part that it's going to be pinned, because very, very often that's what the end result would be that the countersink's wedging action locates the parts, and then the pins can't do their job. They can't even be assembled properly. So, but I would use this in a case where I'd like to get some from some positive location out of it without, having to use pins. Where it's not that, the actual location isn't that accurate, but I know that the parts are going to be are going to stay together in the same spot. Because if I look at this, and let's say I've got a mating part here with a threaded hole, there is the possibility that the parts could shift within the clearance that I have for the counter bore and the clearance hole, correct?
Yes.
And even though they stay clamped together and stay torqued, it's still possible that these parts could shift a little bit because of the clearance holes. But when I go look at this, then I know that once this thing is wedged in here, those parts can't shift anymore. So sometimes I would use that in lieu of pins if the location didn't have to be super accurate. So that's a possibility for using countersinks. So the normal fit clearance hole diameter for the following nominal bolt size. So if I look at a 1/4 inch, what would be the what would be the nominal clearance?
Right.
9/32. And he figured that how? When you look at this chart.
Yep.
Go ahead. Tell me how you did it, Bob.
I added a 32nd to a 1/4 inch.
Yeah, that's basically all you need to do.
But I
So
knew
if you know, if a 1/4 inch is 8/32,
right.
and you add 1 to it, it's 9/32 or 281.
Yep.
So how about three-quarter then?
Experience too. 3/4 is 1/16 bigger than that, so it's I think was that 7/16, something like that, or 7/8. I mean, can't remember.
That would be another 1/8.
No, that's too big. It's a 64th or 32nd, 21/32. I can't remember which way the 32nd falls on it, but it's yeah, I don't remember. It's
a 16th over. It's a 16th over. So 3/4 is 12/16. So the clearance hole is going to be 13/16. Yeah,
right.
13.
There you go.
13 or 813 or 8125.
Yeah.
So
it's one of those things. I don't do many 3/4 inch holes.
Yeah, that's no big deal. No big deal. Okay, so let's look at this now. And again, this is going to be like doing that homework assignment. So
right.
Socket head cap screw needs to go through a piece of metal in order to screw into a plate. The head of the screw should be flush with the surface. Fill in the following table, refer to Appendix B. And again, that's going to be, if you got the book, that's going to be page B7. So we're looking at a 5/16 18 UNC. And the table gives us close fit and normal fit. And so the head diameter, we need to know the head diameter of the fastener. So if we look on B6, it says that the head diameter should be for anywhere from a 1/4 to a 4-inch fastener, which is pretty huge. The head diameter should be 1.5 times the diameter of the bolt. So if the bolt is 5/16, the head diameter should be, this is for a socket head cap screw, it should be 10/16 or 5/8.
Mm-hmm.
Does that sound right?
It does.
Okay, well, let's see if we're right. I don't know. Oh, you know what? This, I think, is the... one of these. Sorry for the silence. One of these slideshows does this stuff twice. So I was thinking this was it, and I was
I
going to
think,
just,
yeah, I
yeah.
think it's this one.
Okay, so let's go through it anyway. Okay, so we look at the table and it's a 4-inch, and we say it's 1.5 times the diameter. Diameter is 5/16, which gives us 10/16. Excuse me, not 5/8. See, I was wrong.
Right.
It's 1.5 times that. So what would that be? Yeah, see, because now this thing jumps to this one right here. And then, so let's see what the, and see, these are the same, this is the same information as before. So let's go back. So here, let's start from here. Yeah, it's kind of wacky.
Yeah.
So we're going to fill in the following table. Maximum head diameter is going to be 1.5 times 5/16, which is, if you take 5/16, turn it into a decimal figure, that is 0.3125 times 1.5. And so the answer would be 0.469, or 0.46875, actually. And if you want to know what that is fractionally, look it up, because I can't tell you off the top of my head. But I can do a better job of turning fractions into decimal numbers. So the max height of the head is the same as the diameter,
right,
according to the table. So
It's
that should be 5/16, or 0.3125. So what's a normal clearance hole for a 5/16 then?
11:30 seconds according to the chart.
Pardon me?
11:30 seconds according to the chart.
Yeah,
at the back
11:30 seconds, right. And the normal clearance hole diameter is the diameter of the bolt plus a 32nd.
Right.
So if it's 10/30 seconds, if the diameter is 10/30 seconds, which is what 5/16 is, and add 1, yes, we should get 11/30 seconds. What's the counterbore diameter? I think it gives you that, doesn't it?
It does. 17 says 17:30 seconds.
17/30 seconds, or 0.53125. And should give you the depth also, or no? No, it doesn't.
No.
So how do we figure the depth again?
The length of the head plus 16th.
Plus the height of the head plus the 16th, right?
Yep.
So if the head is 5/16 and we add a 16th, that's 6/16 or 3/8.
Right.
Or 0.375.
Mm-hmm.
So this is how you would do the homework. All right, now let's look at a countersunk metric cap screw. Clearance hole needs to be a close fit, and the head needs to be flush with the surface. What's the major diameter? Again, we're looking at the table, which is on
B16.
B16.
Yeah, we have B16 and B17.
Yep, B16 and B17. So an 8 by 1.25, the head diameter to the theoretical sharp is 17.92. The head height is 4.96. And then we look at the hole chart for an M8, and it gives us the nominal hole diameter of 9, and then the minimum countersink diameter of 17.92, which is the same as the head, isn't it? Same as the head diameter, 17.92. So we're going to have to add something to that, looks like, in order to
3 millimeters.
yeah. And so when we look at this chart, which is on page B18, I believe, it gives us the fit classes: normal, close, and loose
Right.
for ANSI fasteners, and then B19 gives us the same information for metric. So we look at the metric M8, and these are the fit classes for the clearance hole.
Right.
So back to our problem. The major diameter of an 8 by 1.25 flat countersunk head metric cap screw. The major diameter is
M8.
8.
Right.
What's the head diameter?
Diameter. You would ask me. I just lied. I just turned the page.
Yeah, we just saw it in the chart. That's okay. It's 17.92.
Right. 1792.
Yeah.
Exactly.
This is all stuff you can look up, right?
Right.
So countersink diameter is A plus 3. So it's 17.92 plus 3, which
20.92 or 21.
Yeah, or 21, but the slide says 20.
Right.
Yeah, and I'm not sure what the
that's kind of a weird one because it's where do you go? Do you go with 20 or do you
I don't know if the
21?
author I don't know if the author just tried to
probably try to simplify it.
Simplify it. And even the note here is kind of whacked. It says
right.
Appendix value for the countersink diameter will not be, I'm assuming, the best solution because it is the same as the head diameter, which could result in the head of the screw being above the surface.
Right.
So what they're saying is that you always want to add, I think, the 3.
You always want to add that 3 millimeters.
3 millimeters, right?
Or,
so that
in a standard ANSI screw, 1/8 of an inch.
Right.
Or
So what's the close clearance hole diameter for this? The number 8.
8.4.
8.4.
Mm-hmm.
Let's see. 8.4. Very good.
Right off the chart.
Right. Yeah, basically right off the chart. So, okay. So those are 2 examples that relate to the homework. That should make the homework fairly simple. Let's talk a little bit about standard parts. What are standard parts?
Anything I can buy off the shelf.
Yep, anything you can buy off the shelf, whether it's cylinders or slides or grippers or, nuts and bolts. Yeah, nuts, bolts, washers, and, all that good stuff. Those are all standard parts unless you're making a special or you're taking a purchased part or a standard part and you're modifying it somehow.
Right.
In order to, in order for it to perform a specific function, which then makes it a non-standard part and makes it a detail.
Mm-hmm.
So yeah, and they're anything that can be purchased, from a catalog or website, and they don't need to be drawn unless they're being modified. So on a standard parts sheet, that we should provide enough information to purchase the item. So that should include, the part number, the manufacturer's part number, the description, material. This is just, and you might even list the vendor information unless the company you work for doesn't want you to do that. But again, if you want it specifically from a source.
Yes, those sources are a lot of times just because you made an agreement. Say we have Fastenal here in Rockford, and they make all kinds of fasteners. And so maybe we've
Yep.
gone out as a company and said, we want you to supply all our screws, but we want a special deal.
Right.
All our fasteners.
Right,
And
but
so,
what I'm saying is if Fastenal gives you bolts that are of a certain quality, then and they meet your
requirements.
they meet your requirements for the most part. But
Right.
then again, you have, let's say you need to have some bolts that are manufactured to some stricter tolerances than the ones that Fastenal provides. Say you go to Unbreako. I don't know if you're familiar with Unbreako.
I've heard of them.
They they have some pretty nice catalogs. They did. I don't know if they're even still in business anymore. But if I wanted a bolt that I know was going to be under a lot of stress and repeated cycling load, I would specify that I wanted my stuff, my fasteners, these particular fasteners specifically purchased from a company like Unbreako,
Right.
because I'm real familiar with their, with their quality and how they manufacture. What my other source might be giving me great bolts, but they might be coming from a source that I don't really know enough about. So I would definitely say, hey, I want this stuff purchased through a specific vendor for a specific reason. And
Right.
if your purchasing department has an issue with it, I would say, you know what, that's too bad, because I can't trust the stuff, the hardware. For all I know, those guys are going down to Home Depot or Menards and buying this stuff.
Right. Exactly.
I don't know that.
Well, and that's the thing. You're in your description. You're doing a description of it, but also where I don't remember where it's at, but somewhere in there, like in the materials, you're telling them the material, but you might also like special requirements for nuts or for bolts and stuff. You might be looking for certain hardness.
Right.
And you'd have to specify that.
So I would call out a grade. If that were the case, I'd call out a grade, like
right,
a grade 8.
Exactly.
Like a grade 8 or a grade 5.
Right. Unbreako's still in business. I just looked them up.
So, I would, you definitely call it. Now, in a situation like that, I don't, again, even though it's certified grade 8, if I don't know the vendor, I might still be a little cautious about that.
Right. You might question, well, yeah, I would too, until otherwise.
So anyway, all I'm saying is that you could, call out a vendor in this information also. So what we're looking at here is a standard parts list. Typical, there's a find number or an item number, which is what's usually called. And that should correspond to a item number on an assembly drawing.
Right.
And then the quantity, the part or identification number, which is usually going to be a vendor part number. Description, size, anything that, series or style, if it's a, if it has that kind of information, and the material that it's made from, anything and everything that you can put in here in order to assure that purchasing people get the parts that you want. Normally these parts lists are made from the assembly drawing bill of materials, and the bill of materials on an assembly drawing usually specifies all of the details and all of the purchase parts. So this is usually made after the the assembly drawing is done, and it's usually a takeoff, or a copy of the purchase portion. Unless you have to, you have long lead times, then you might want to put together a parts list of at least a partial that's got long lead time items on it, so that they can be ordered, and going through their process while you're designing the machine or the station that you're working on, so that when everything gets made and all the rest of the parts come in, those long lead time parts will be there too. So that happens as well. Okay. that's pretty much it for that. Um, are you guys working on the P150 at all?
Yeah, I've started.
Okay. Do you have any questions on it? Because
I'm still, we looked at that last week, I think, really briefly, but I'm still concerned about those simulated tapped hole things and
yeah,
how to change that so that
yeah,
really, you got a real hole call out.
yeah. It's not a real hole. It's not a real hole, but the call outs should
The
show
call
up.
outs are right. Yeah, they showed out with the right sizes and stuff, but
But so what I expect from you is to modify a call out so that
okay, just modify that call out that's
yeah,
there.
so that it looks
Okay.
so that it's the
So it
way it
meets-
should be.
Okay.
That's the way. So that's the way it should be. So let me. Why I don't know why. I guess I miss. I miss Firefox because Firefox usually asks me where if I want to save or open the.
Yeah.
And this and Edge and whatever they did to Chrome and Edge now, it seems like they don't do that. And I thought they did before.
No. Chrome just dumps it in a download, and so does Edge.
Yeah, and I'm not real happy with that because then I got a whole bunch of stuff in the downloads file that I don't really want to have there.
Right.
So I got to keep.
The good thing about Firefox though is if you go and you click on that download button, it'll ask you if you want to show it in the folder, so you can show it in the folder it's actually in and then move it if you want. But it's still a pain in the butt.
Yeah, well, I think Edge does too because.
Yeah, it does.
Oh, okay. Oh, I didn't actually need to download them, I guess. I had them in, I forgot I had them in here. So here's the part. Did I have it? I didn't have a drawing open for it. Okay, so. Or is this my finished? Oh, this is my finished one.
Oops, don't want to show us that.
I don't want to necessarily show you that one.
So, well, it's small enough, can't read it anyway.
Take a quick look. Take a quick look, and then poof, it's going to be gone.
Yeah.
So, but if but if I do a video of it, once I post it, anybody can stop and take a look at it.
Right.
So, I don't have an issue with that. I'll be honest with you. I don't really have too much of an issue. I'm more concerned with you guys getting the feel for how to do this rather than.
Sure.
At this point, we're still in the early learning stages of using SolidWorks. So, and under the circumstances, I'm not as concerned about how well you've picked up the basic techniques, because if you go on from here, you'll have plenty of time. And then next week, Monday, I'm going to try to spend the entire day just talking about SolidWorks and having you, if you have questions about certain techniques or commands in SolidWorks, start compiling a list, and we'll go through that stuff on Monday. I'm trying to make that a SolidWorks day, so we can talk about parts, drawings. Maybe we can go over the assembly again some more. So if you have some questions, then let me know, on Monday, and we'll walk through everything. So anyway, I think what I did then was I just said, hey, I'm going to make a drawing of this guy. I'm going to use a standard. And I'll just pick a C landscape. So I'm pretty sure that's what I did. And I brought in the front and the top view and the right side view. I can't bring anything else in, right? So,
Right.
and at least in this, and so it did this for you guys too?
Yeah. It
Yeah,
did it for me anyway.
okay. So again, this call out right here is pretty much all you need, except that my spacing's not right here.
Mhm.
Now, I don't remember if I added this in at some point, because actually last semester I gave them a part that had the correct holes in it. But that seemed, I don't know. It seemed, I'm even defeating the purpose here because I'm giving you the right call out. This is the right call out, so you don't even need this one.
Right.
You can eliminate that. This is the correct call out here, so you should be able to eliminate this. And then I didn't put another call out in for this one. But if I say, hey, I need
The auxiliary view.
I need a auxiliary view. Okay, so it doesn't give me a thread call out there, but I have this. So this is the only one that you're probably going to have to modify, and even that doesn't, and it shouldn't be on this view anyway. It should be
No.
over here,
Right.
right? So, if you want to eliminate that, that's fine.
Right.
And
So, curiosity's sake, in that view, will the whole call out work on that at all? So you can include that chamfer in there?
the whole call out.
Yeah.
Is that what you're asking? The whole call out.
Yeah, yeah. Will that actually work on that if we did a whole call out on there?
Yeah.
Yeah. Yeah. Okay.
Yeah. Yeah. That's no problem.
Okay.
But
well, actually, it's not showing us the tap though. That's just showing us the depth of the hole.
Right.
So we'd have to have the tap.
Right.
Well,
I have a couple of things that I need to modify here, because it didn't ask me if I wanted to do inch or metric.
Oh yeah.
So okay. So that should be metric.
Right. Right.
And then the other, this is also kind of wacky, because the diameter of the clearance hole that's in here is bigger than the thread. So,
oh, goodness.
Let me go in here and fix my. The other thing I have to fix is my drafting standard, because even though it says ANSI, you can see my dimensions were not ANSI.
Right.
Right. So now my call out looks better.
Yeah.
So yeah, I guess I'm kind of, I would say, if you want to eliminate the, I don't know who put this thing together. So I kind of left it alone, just because I thought, well, this is an opportunity for people to try to
play around.
Yep. Yeah, and do a little investigative work and find out what's going on here. And will they realize that this, but now I'm giving it all away.
Well, yeah, but even I would have recognized that, though. An M16 is not the same as 17.5.
Yeah. So, I mean, this thing's already making the thread too big.
Right.
So, or making the hole too big so that you can't really thread it. So, and for me to change the part now, especially if people have already started, and they've downloaded and saved it, I don't really want to go in there and make any changes to it. I'm changing my font size here for this guy. Still a little big. Just makes it. But, you know, those are basically all the views you need. You're going to need
Okay.
you're going to need a revision block.
Revision table. Right.
Yeah, is this in fact all of the views you need? Let's take a look at this guy and make sure that there isn't anything. Yeah, there's nothing hidden on the other side. So yeah, you should be good. Yeah, so when you look at this, you see the thread is actually
Right.
smaller.
it's not very deep.
So what would you do if I were going to fix that? But see, I don't expect you guys to be able to do this because what I would do. Well, here's what I would do. I'd actually go back to the part, and that countersink has got the cosmetic thread here.
Right.
So I would double click this guy or right click it and say, hey, I want to modify that feature, the cosmetic thread. And I'd maybe change it to an
what it's supposed to be.
Well, I don't know if it's supposed to be an M20.
Okay, sure.
But if I did that, what would happen? When I go back and look at the drawing, I don't think the note's going to update. But at least it looks a little more reasonable now, doesn't it?
It does.
You know, but that's not something I would necessarily expect everybody to do. So now I got to change my call out because it's not a, you see that it's not a, it's not directly tied to the, and I can't call out that because it's just a cosmetic thread. I can't put a whole call out on it either.
Right.
So I have to modify this. If I'm going to do that, I have to modify it manually by 2.5, right? And I don't really need anything else, do I? Except I need any spaces there, and this should be uppercase.
Small. Yeah.
Right? Uppercase.
Yep. And we need a depth on that thread.
And we need a depth on it, right? So how do I do that? How do I figure the depth? I could. Is it from here to here? You think?
You could. Yeah, you could. But then that's well.
Or is it from here to here?
I would think it'd be from there to there personally, but it's hard to tell.
So what you do is you pick one
and use it.
And use it. All right. And so I say, hey, okay, so how do I do that? I need to add a symbol. I need to add a symbol, right?
Yep. That line with the flat line on the top, perpendicular line going down with the arrow
symbol, like this right here.
Right.
Okay.
Exactly.
So there's no option for me to do it here, but there is an option for me to use add symbols when I look at the property manager. So this one right here says add symbol. The center line plus.
Right.
You see all these buttons here. So if I click that, then I look around, and I say, hey, where's do I see it? No, I don't see it. I don't see it in there. So I go to more symbols, and I don't see it here again. So where am I at? I'm looking at modifying symbols. Let's look at just geotolerancing. Depth won't be in there. Whole symbols, and there it is.
Yep.
Okay, the depth. So I select it up here, and then I say OK, and it adds the depth symbol right to it. So what did we say it was? 12? It looked like 1195. So a depth of 12. And there we go. And so now my note at least makes sense.
Right.
And the look of the thing makes sense, but I can't mess, the leader doesn't like that. Well, now it does. So what I might do after all that is done, instead of having two leaders on this guy,
Mhm.
I might go ahead and copy this, do a Control-C on this, do a Control-C on this guy if I can. I can't, well, I can't,
You
because it's
can't.
not just text, it's specific dimension text.
Right.
So if I want to add, what I want to do is I want to add this to this note. Okay, so here's what I do. I select it so that I get the property manager.
Right.
Select it to get the property manager, and then go down to where the dimension text is. And I can't see the end of the line here. And so I can do one of two things. I can stretch this out so that I can get my cursor to the end, and then hit enter to return it over here. Or when it was like this, I could put my cursor somewhere in that line and hit the end key on the keyboard,
Mhm.
and that's going to put it all the way to the end. Then if I hit enter, I should get the carriage return, and it should put my
Yeah, put it down one
my
line.
information there. So now if I do a Control V, now I get that information added to that
Right.
note, right? And then I can eliminate this note completely. And then you got to remember on these notes that you need to justify the text to the left. So there's left justified text. And if I want to change the location of where the leader hits it, I can do that for top justify, middle justify,
Right.
or bottom justify. I like top justify. So now I added all the information to this one note. And now it looks a little bit more compact, and plus my leader points to the center of this thing, no matter
Right.
where I put it. But I don't expect people to go in there and modify the part. What I really expect is that they just say, since they're watching the video, hopefully, hey, I'm just going to change, or even if they just use the original information, the M16, I don't care. As long as they maybe go ahead and do what I did here,
Sure.
which is added all to the same note of the countersink. We'll see if people can get that done.
Okay.
Okay.
Thanks, Frank.
And then, anything else is going to be standard based on the
Sure.
on the project sheet. Whatever the instruction sheet says to do. The modified instructions here. It says feel free to practice. So.
Right.
But it does say dimension everything. Okay, so you got to dimension everything. Consider some possible applications of GD&T, blah, 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 revision table and balloons, tolerances. So I'm just looking to see how much time people put in this, and whether or not they actually try to add, how much of the stuff they add. If you add it all, I'm going to be pretty happy. If you don't add much, then I won't be as happy. So that is that's the gist of that. Any other questions you guys might have?
No,
Okay.
I think I'm good.
I'm good.
Okay. All righty then. Well, then we'll call it a day, and I'll go ahead and stop the recording, and we'll see you on Wednesday. And for those folks for the afternoon class, I'll see you in about 4 hours.